All right, so we are beginning lesson or topic 6, and today we're going to be in 6.1, and we're going to talk about translations. So we're going to talk about some definitions. I'm going to give you a brief overview, show you some of the notation you're going to use, and then we'll get into a few example problems. So you don't have to have this little umbrella in your notes. I just did this to kind of show you what I'm talking about. All of topic 6 is talking about transformations. So think about Transformers. If you guys ever played with them or watched the movies or whatever, the Transformers, right? They can change, move, and they look completely different at the end, right? They can move in a whole lot of different ways. All of what we're talking about in topic 6 are all these different transformations that we're going to talk about. Under the umbrella of the word transformation, there's a whole lot of different transformations that can happen. Translations is the ones we're going to talk about today. That's the easiest of all of them. Then you've got reflections. If you think about reflecting in a mirror, right? A mirror image of itself. Rotations means it turns or spins. And then dilations, what happens when your eyes dilate? Okay, they either get bigger or smaller, right? When your eyes dilate, change dilation, they either get bigger or smaller. So all of those fall under the umbrella of a transformation. Okay, and the one we're going to talk about today are translations. And I wrote it last, but I am going to just mention it first. It's also called a slide. And if any of you ever have played with, they drive me bonk. I can't do them. It's one of the few puzzles that I just cannot do. But the puzzles that have like 12 blocks, but one of them's missing, and you have to sit and slide them left and right and just move them left and right. And all you can do is slide, right? You can't take it out. You can't move it. You can't twist it. All you can do is slide it up and down, and you can sit and try to refigure and make an image, right? That's what transformations are. All you can do is slide up and down and slide left and right. You can't spin it. You can't flip it. You can't twist it. You can't make it smaller. That's the only thing that a translation is. So of those 3 things that I have listed there, we've just pretty much already said it, stays the same size and the same shape. So nothing changes from the original to the transformed, and or the translated, and we're going to get into some terminology about what we call those here in a minute. But the original shape and the translated shape are going to be identical. Okay, shape, size, side length, angles, everything will be identical. It only moves left, right, and or up and down, and there's no spinning or flipping, okay? And like I said, they're called a slide because if you think about something, if it just slides in a grid-like pattern. All right, so let's flip to the next page, and I want you to be able to refer back to that if you have a question. So let's go to the next page. And before we get into the little fire pit story problem, I do want to call your attention. I'm not going to spend a lot of time on it because we just said it, but a transformation is a change, right, in the position, shape, or size of a figure. So that's that big umbrella I talked about. And under that umbrella, there's a whole lot we can do: translations, reflections, rotations, all the ones I have listed up there. Today, we're going to hone in more specifically on just the translation part. Okay, just the translation part. And that is where I said it's also known as slide. So if you want to, out to the side, it would not be a bad idea to put the word slide there, just to remind yourself that a translation is a slide. Okay. So if we look at this fire pit problem here, we've got a landscape architect shows a plan for a new patio to a client. The client wants the fire pit moved. And here's the move that they're requesting. They want it 6 feet to the right, and they want it 3 feet further from the house. And since the house is right here, further from the house would be down. Okay, so they want it 6 feet to the right, 3 feet away from the house, or in this case, that would be down. So what this shows us here is that exact same drawing, and that's what they did. They went 6 feet to the right, and then they moved it 3 feet down. Notice in its new position, which is right here, notice that it's not turned catty corner. With a square, it's kind of hard to tell. It's not rotated. It doesn't look bigger or smaller. It is just simply slid to a new location. Okay. So under this try it, it says the client also wants the small table below the window moved 5 feet to the right. Where should the architect place the small table? Draw the new location of the table on the plan. So if this is our plan, and here's the house window, it's kind of hard to see it, but there's the house window. So there's the table under the window, and the client wants it moved 5 feet to the right. So you would move it this way. Now on this, it's kind of hard to tell what 5 feet is. You're going to have graph paper or grid paper or grids on your Sabas to do these. So we're just going to guess what 5 feet is, right? And we're going to place the table in the exact same size and shape as it was before. We're just sliding it over 5 feet, and that's a translation. It is. Kind of think of it as if I'm speaking English and you don't know English, and say you only know French, and we have a translator. My translator isn't going to jumble up my sentence. They're not going to turn it around. They're not going to make it a big, they're just going to say what I say to you. They're going to translate exactly what I say to you. And that's kind of how you can remember what translation is. It's not changing it, right? You don't want a translator. There was some show, oh, we were watching The Rookie the other day, and she didn't know he spoke Spanish, and so he said something really mean, and she tried to soften it. And so when she translated it to the Spanish people in the car, she made it sound really nice. He's asking, would you please do this or that? And he got upset, and he showed that he spoke Spanish, but he was like, why did you not just say exactly what I said? I don't need you to change it. So that's how you can kind of remember that translation is taking exactly what was and just moving it over, okay? Keeping it exactly as it was, all right? Okay, so we've done the client move. We've moved the table 5 feet over. Let's look at some terminology now, okay? In a transformation, the original figure is called the pre-image. Just think of pre-game, right? It happens before the game. So pre-image is the before image. And then when you're referring to the transformed image, whether it's translated, reflected, it doesn't matter how you do it, it's called the prime image, okay? So those are the terms that you'll get used to hearing. And I want you to know how it's notated that it's the original and it's the prime. Notice the original has each vertex named A, B, C, D here, okay? Those are here, A, B, C, D. The image that was transformed, notice the difference. This A has like that little, it's called a prime, but that little tick next to it, okay? That's how you notate that it's the transformed image, okay? Or it's not the original. Notice the B, it has that little tick. This is right here is what I'm talking about, okay? It has that. And if it has that, that means it's not the original image, it's the prime image, okay? And you won't necessarily do this because it would make your graph an absolute mess. But what I want you to notice is if you start at point A, okay? And this tells you to first graph the vertices A, B, C, and D, which hopefully you guys are good at graphing points, because that you'll have to graph points here on a graph, but just graph the X first, then the Y, you know, go over how many, go up or down, however many, to graph a point. And then it says graph the vertices of A, B, C, D prime. And here's the translations it tells you. It says go 8 units down, right? 8 units down. And then it says to go 3 units to the left. So if I go to point A and I put my pencil on the original, the pre, right? The pre point A, that's my pre-image. From there, I would fall 1, 2, 3, 4, 5, 6, 7, 8, turn the corner and go backwards 3, and that's where I land my A prime. So A and A prime are exactly 8 boxes down and 3 boxes over from each other. Then I go to B and I do the same thing. I put a point on my original B and I fall 8, 1, 2, 3, 4, 5, 6, 7, 8. I fall backwards 3, or I run backwards 3, and that's where I land my B prime. Then you do the same thing for C, okay? Find your original or your pre-image, your C, and drop 1, 2, 3, 4, 5, 6, 7, 8, backwards 1, 2, 3, and that's where you drop C prime. And then you do the same thing for D. You find D, that's the original, you drop 8, you go backwards 3, and that's where you land D prime. Now, if you do a lot of dots or lines to do this, I would do them very lightly, and then I would just go back real lightly with your eraser, and I would erase all of that so that your images don't get too cloudy and weird, right? And you can very easily, when I get rid of all this extra stuff that I was putting on there, because I just put it real light with my pencil, you can see that my pre-image and my prime image are identical, right? They're same size. They haven't been twisted. They haven't been distorted in any way. They don't reflect across each other. It's just the one image was moved to a different location and still looks the same. That's a translation. And notice that what it says over here, okay, that angle A of the original, how do I know it's the original? Because there's no slash mark here. Angle A and angle A prime equal each other. What that means is angle A up here and angle A on the prime one are going to be identical because with translation, nothing changes, right? Same shape, same size. Angle B's equal each other. Angle C's, angle D's. Side lengths equal each other. That's what they have here. Side length AB, I'll do that in green right here. Side length AB is this side length, whoops, right here on the original. On the prime, it's in the same spot. Notice that they equal each other. Sine lengths are the same. Angles are the same. Everything's the same. Okay? Sound good? All right. So now, what if we're given the original and we're given the prime and we're asked to say what the translation was? Well, the way you do that, and always do it in alphabetical order. It will really be helpful if you'll do that. Always do a figure in alphabetical order. So P is my first letter that comes up in the alphabet. So I find the first, the pre-image, and I find the P prime, and then I count how much up and how much over. I go up. See if this is a half a box, this is a half a box, and this is a half a box. I go up 2, I turn the corner, and I go over this way 1.5. Right? I went up from, it's very important that you go from original to the prime. If you go from prime to the original, your moves are going to be backwards. Okay. So I went, and it tells you right here, 1.5 or 1.5 units to the right and 2 units up. Okay. And I don't really care what order you tell me that. I don't care if you say up and down first and then left and right or vice versa. It doesn't really matter. Just watch if you're doing it on Savvas. Make sure if they're asking the up move, you put up. If they're asking left or right, make sure you keep those straight. Right, Davis? Got a question? Are you sure? Okay. So we just now always make sure the way you check that it wasn't a dilation and that something maybe didn't get smaller or moved around is always check your other points. Now I'm going to erase all this when I'm done because it makes it a mess, but I'm going to go to my original Q and I'm going to make sure that to go from Q up to my Q prime, it was the same, and it was, right? It was up 2 and over 1.5. Then I'm going to check R. So I'm going to find my original R. I'm going to go up 2 and I'm going to go over 1.5 and I'm going to land on R prime. And then lastly, I'm going to check S. There's my original. And to get to S, I would go up 2 and over 1.5 to land on S prime. So all of them are the exact same move, which means it didn't dilate, it didn't rotate, it didn't do anything. It just slid up into a new position. Okay. And you really want to be careful, and I'll show you why on your homework, but you really want to keep in mind which one is your original and which one is your translated one, okay, or your prime one, because it will change kind of how you answer as far as is it really an exact, is it really the exact same size and the exact same shape? Because for that to happen, all vertices have to move the exact same number of boxes over and up, okay? All right. So on this triad, it says triangle ABC is translated, and here's the translations right here. 5 units to the right and 1 unit down. So we go one at a time in alphabetical order, and everybody should be doing this, okay? 5 units to the right and 1 unit down. So I'm going to put my pencil on point A, my original point, right? This is my pre-image. And I'm going to go over 1, 2, 3, 4, 5, and down 1. And that's where I'm going to land it. And right away, please do this. If you don't label it, it is not complete. Label it quickly, A prime, so you don't forget which point is which. If you start moving them all and you don't label them, you're going to really lose what is what. All right, now we're going to go to B. And again, we're going over 5, down 1. Every point or every vertice has to be moved the exact same. So over 1, 2, 3, 4, 5, down 1. And that is B prime. Label it right away. And then I'm going to go to C. and I'm going to go over 1, 2, 3, 4, 5, down 1, and there is C prime. And then, and this is where I said rulers are important. Make sure that you get your rulers when you're doing these because you're going to need straight lines, but you connect the vertices to create this identical image, but it is slid over to the right and down 1. The whole image, just as it was, is slid over. Okay. Now it wants to know if angle A, this is right here, if angle A on the original, right, or the pre-image, if angle A is 30 degrees, what is angle A prime? Lane? 30 degrees. Okay. If side length AC is 10 centimeters, then side AC prime would also be 10 centimeters. So it doesn't matter. Side lengths, angles, everything is identical with translations. All right. On the key concepts, again, this is just everything we just talked about. Notice the terminology. We've got the pre-image. We've got the image, and the image is always notated by those prime marks. Okay. Make sure that you put those on there so that you differentiate between the pre-image and the image. And then notice here, right, all the angles are the same. All the line segments are the same. As far as length, everything stays the same. Look at this one on the do you know how. It says which figure is translated from figure A. So here's our original, right, our pre-image. This is our original one right there. Which one of these, B or C, which one of those is a translation? B, okay. Why not somebody else that had their hand up that knows the answer? Why not C? Carter? Yeah, it flipped over, pointing the other direction. And for it to be a translation, it has to be exactly the same, facing the same direction, everything. It just has to be slid over. And if you ever want to test it, now they don't name these vertices, but if they did, this top corner would be A, which is here, and the A top corner here is right there, right? And they're 4 boxes apart. Everybody see that? So if this were truly a translation, this box and this box also have to be 4 boxes apart. And they are definitely not. They are much further than that apart. So it doesn't even pass the test of having the vertices match up. Okay. So yes, figure B. And then for explain, you would just explain that each vertice moved up exactly how many? 1, no, it moved up 2 to touch, but think about matching points. You want the top corner matched with the top corner. So how much did it move in order to go top corner to top corner? I think it went up 5, right? 1, 2, 3, 4, 5. Did all your other ones go up 5? Check this corner to this corner, because you always want matching corners. If I color code all these, right? And I do that a lot just because I think it helps everything stand out. If I color code all these, what you want to be able to happen is if I could just go up to the screen and if I could pick figure A up, move it up and lay it flat down, all my red, blue, purple, and green would match up identical. So when you match corners to test and count, make sure that you're keeping the right corners above each other, okay? And in this case, if we were to have to describe this translation, it would be up 5 because the whole thing just slid up 5. Okay. And I've had most everybody today has said it slid up 2. And that just means that the top of this one touched the bottom of this one, but that's not how you count translations. Okay. All right. Let's see. I think all of that was fine. For your homework, go to the next page. You're going to do all of it on the front. You're going to cross out number 13, and then you're going to do 14 and 15 on the back. And if you ever forget, it's always where? On Canvas. Good. 15 is a part A, B, and C, so make sure you pay attention to all 3 parts. And you've got, what, about 8, 9 minutes. You can probably knock out a few of these right now. I will say this, just to give you a hint, because this tripped everybody else up. Look at your numbers of your boxes on number 7. They don't go by ones. Right, Aiden? What do they go by? Okay. I'm giving you some really important instruction here and you're missing it. It's going to mess up your graph. So pay attention to that on number 7. And then on number 8, this is one of the ones I said, be careful that when you're counting, make sure you're going from A's tip to A's tip. It's really easy because they're overlapping. Sometimes it kind of makes your eyes cross and it makes it hard to see where you're landing. So make sure you're going A to A, B to B, and C to C. And the A prime and the C kind of are close to each other. So just make sure that those don't get overlapped in your eyesight. Okay?
Wait, so is the tip always the one that's at the bottom?
Well, the vertex, I said the tip, really the mathy term for that is vertex. So vertex A and vertex A prime are what you want to count. And then vertex B prime, vertex C, and vertex C prime. But as far as how they're labeled, it's just, you can do it it's however the book has it. All right, I will quit talking. You guys have got about 6 minutes to knock a few of these out. And then this is due at the beginning of the hour tomorrow. If you're at home and you have any questions, please shoot me an email.